Happy Friday. So we're talking more about definite integrals in terms of area under a curve. I alluded to this, or actually didn't allude to it, I think I said it yesterday. But keep in mind that area above the x-axis is positive. This is kind of convention, what somebody decided. And it also, I guess, makes sense with how math works, how graphing works. Area below the x-axis is negative. Okay, so we have a picture. And we're going to talk about integrals. I just did an about like a major Minnesotan there. Sounding really Minnesotan. It's really bad when you listen to yourself all the time. So if we look at the integral from 0 to 7 of f of x dx, and this whole graph is f of x. From 0 to 7, it looks like we have this trapezoid. So technically, the area under the curve is just the area of that trapezoid. So we have 1/2 times base 1, which is 7, plus base 2, which is 3, times our height, which is 4. So that's 1/2 times 10, which is 5, times 4, which is 20. So the area under the curve of f of x, or the integral of f of x from 0 to 7, is 20. Next, let's look at -6 to 0. -6 to 0 is this shape here. We can assume this is half of a circle. So then the integral from -6 to 0 is just the area of that half circle, and it's below the x-axis, so it's negative. So we have a negative, and it's half a circle, so 1/2. Area of a circle is pi r squared, so we have -1/2 times pi times our radius, which is 3 squared. So we end up with -9 pi over 2. Now let's look at -8 to 7. So -8 to 7, starting over here, we have this triangle. So the area of that triangle is 1/2, and it's positive, it's above the x-axis, times our base, which is 2, times our height, which is 4. We also have that half circle, which we already found. That was -9 pi over 2. And finally, we're going from -8 to 7, so that's starting here and stopping here. So we've accounted for that triangle, that half a circle. Now we have to add in our trapezoid, which was 20. So this is 4 minus 9 pi over 2 plus 20. So our overall area is 24 minus 9 pi over 2. And again, the integral of f of x dx from -8 to 7 is the same as the total area under the curve from -8 to 7 of f of x. Now let's look at from 4 to 10. So from 4 to 10, I'm going to get rid of these vertical lines. From 4 to 10, that's from here to here. So we have part of that trapezoid we found the area of before. And to find the area of that trapezoid, we will do 1/2 times the bases added together. So this is 3, the other base is 1. So 1/2 times 3 plus 1 times the height, which is 4. And then we have the other half a trapezoid, and this is going to be subtracted. It's not about half, it's partial trapezoid. Sorry for calling it half. The other partial trapezoid, which is underneath the x-axis, so it's negative. So we'll subtract 1/2 times the sum of the bases, which is 3 plus 2, times our height, which is 3. So we end up with 8, that's this part, minus this part here, which is half of 15. So 8 minus 15 halves. So that's 16 halves minus 15 halves, which is 1/2. So you end up with a net positive area of 1/2 because this trapezoid is slightly larger than this one. Then from 0 to 13. So now we're looking at from here to here. So we're going to have the area of this total trapezoid, which is positive. We already found that up here. So that was 20. And then we also have this trapezoid underneath, this whole one now, not just the partial one we found before. And so that's negative because it's beneath the x-axis. So then we have 20 minus 1/2. The bases added together are, this is 6, 7 to 13, plus 3. And then the height is 3. So this is 20 minus, let's see, this is half of 27. So 20 minus 27 halves. This is technically 40 over 2, so 40 halves minus 27 halves, which is 13 halves. So still a net positive area because the trapezoid above the x-axis is larger than the one below. Okay, so now let's move to some similar problems where we're not looking at that picture anymore. So the integral from -2 to 3 of 7 dx. Well, if we think of 7 as a function, let's draw it. Oh, that's 7. I mean, you can't tell that it's 7, but I'm going to tell you that's, I'm going to pretend like that's y equals 7. And from -2 to 3, if we make a rectangle out of this, -2 to 3, is what we have. So this area is just the area of a rectangle, right? And this is, well, 2 plus 3, this is 5. The height is 7. So the area under the curve is 5 times 7, which is 35. For number 7, absolute value of x, area under the curve from -3 to 0. Well, let's sketch it. So absolute value looks like that. From -3 to 0, can make a triangle. We can find the area of triangles. We'll pretend that's a right triangle. It should be. My drawings are just bad, as we all know. So absolute value of x, so at -3, the y value is going to be 3. So absolute value of -3 is 3. So then the base of the triangle is 3. The height is 3. Area of a triangle is 1/2 base times height. So this is 1/2 times 3, which is 9 halves. For this last one, hopefully you guys know that square root of 16 minus x squared is a circle with a radius of 4, because the full equation of that circle would be x squared plus y squared equals 4 squared, which is 16. Okay, and then if you solve for y, that's where the square root of 16 minus x squared comes in. So if we sketch this, since this is a positive square root, it's the top of the circle. So this is 4, and the top of the circle looks like this. We're going only from 0 to 4, so that's this quarter of the circle right there. So then our area is going to be, it's above the x-axis, so it's positive. All of these that we've done in 6 through 8, they're all positive because they were all above the x-axis. They just happen to be. So here we have the area of a circle, but it's a quarter of it. So 1/4 times pi times 4 squared. It's 1/4 of 16 pi, which is 4 pi. Oops. Not a very nice looking little cloud. All right. So the point here is when you have familiar shapes, shapes you know, or when you have straight lines, you are able to find the integral by literally just finding the area. And it's back to what we did on the first day when we were estimating with number of squares. But in this case, we're talking about shapes where they're exact shapes. So our triangles, circles, partial circles, trapezoids, triangles, etc.